Good morning, Dreamforce 2014 on the second day. I appreciate everybody taking their time out to come here. I'm competing with not only prime seating for Mark's presentation, but also for lunch, which I see some of you have brought today. I hope you brought enough for everybody. Today we're going to talk a little bit about advanced development using Apex design patterns. Time today definitely is a challenge. We only have 40 minutes together, so we're going to concentrate on one pattern. But within that, I think you're going to see some sub-patterns that could definitely be helpful. We're also going to talk a little bit in the beginning about good design, at the end about test, so we're going to cover the whole SDLC. And I'm even going to throw a little bit of an Easter egg in there when it comes to how to test your batch programs. So let's get to it. So, safe harbor slide. I don't work for Salesforce, but in case I happen to mention anything that might be forthcoming, just base any decisions on what's existing and not what's coming. So by way of introduction, my name is Bob Nunemaker. I'm a senior systems architect at Citrix Systems. I'm certified administrator as well as an advanced developer, and I fully recommend everybody get your certifications so you can invest in yourself. Just a touch about my company, Citrix. We are a $3 billion a year company. We're headed towards $5 billion. It's called the X5 project. We have 9,000 employees in over 35 countries, and we are number 1 and 2 in the spaces we compete in. And our motto is simply that people can experience life and work in harmony. So let's talk about design just a little bit, because this is an example of poor design. I think everybody would agree with that. And in my opinion, design is one of the most overlooked parts of the SDLC. It's rather inconceivable to me how so many people will jump right into development. This is where you need to spend more of your time. And just like this was just set up as a standard building. But the problem is the guy didn't take enough time to study the climate, study earthquakes, study the soil, any of those things, and this was the result. So the same thing can happen to Salesforce if you don't do your design properly, and not doing enough time now is going to bring you problems later, I can guarantee it. So technical debt that goes unresolved quickly can have similar effects. Just by way of explanation, technical debt is just simply making a decision now for your deployment or development because of other challenges, resources, knowledge, whatever it might be, and now you've deployed something that might be substandard. It's not optimal. This goes over time, and just like monetary debt, it accrues interest, and it becomes harder and harder to implement a fix later. So the moral of the story is, take care of it now. And at the very least, if you must deploy something that's not optimal, keep an inventory of it so you can come back and revisit it. This is an example of good design. How did the same fail become a success? Well, it's really not the same. When they decided they needed to stabilize this tower because it was in danger of falling, they spent 7 years making that happen. The first 4 years was all planning. So this just shows you the value of good design. They went in there, really studied the soil, the structure, the climate, earthquakes. So the conclusion we have here is don't skimp on your design, because they had to come back to this. It took 7 years. This tower went up originally in 4. So it took them almost twice as long just to stabilize the thing. So an hour or 2 is the best investment you can make on these type of things, because it's going to save you dozens of hours down the road. So rhetorically, I'd like you to ask yourselves, how many of you have triggers or classes that have hundreds of lines just all jury-rigged together, and it's just a mess to look at? How many of you have had to reverse engineer code because of something that comes in and you're looking at this code and saying, what the heck were these people thinking? How many of you don't code but wish you knew what was going inside those triggers? I know everybody in here is not a developer, or at least I hope not. And how maybe you wonder why you can't get your contractors or new hires to code consistently. They have their preferences, you have yours. Everybody is coming from a different background, whether it be Java or .NET. This is a way we can talk about to make these things happen consistently. Or possibly maybe you don't want scalability and maintainability to be simple platitudes. You want them to really mean something. I think this design addresses all of that and even more. And even if it doesn't really fit for you, maybe it gets you down the road to thinking about some of the ways you're doing things today. So by objectives, I just want to give you another flexible tool for your development. Doesn't have to be something you use 100% of the time, but if it fits, use it, or maybe it just provokes some thought. Something in the way you're going to start there sitting there and saying, you know what, maybe we shouldn't be going down this road. We're not going to be able to go down this road forever. I want to provide a pattern for managers and developers and analysts. So this way, those guys can go into this code without having to really know what Apex is or what it's doing. But if you use what's called the dispatch in this thing properly and comment it properly, you can actually tie it back to requirements and let them see right there what it was for. They don't really have to know. As long as it's named properly, they're going to know what's kind of going on there, and they can come to you for additional information. Among the advantages, in my mind, it scales very well. We haven't had one that hasn't been able to handle what we've thrown at it. It's very readable and easy to maintain. It's very modular and a single point of DML and error handling. This is actually my favorite piece of this design. And it does limit reverse engineering and regression testing. All of this means stability. Stability means happier customers. And for those of you who may have seen this last year, there are definitely some changes to it from last year, so hopefully you'll be able to pick those out. So it's called EDA. So what is EDA? It's Event Dispatch Action. That's all it is, and you'll see a little diagram on the bottom. To know what EDA is, just learn the parable of the plumber. The plumber, okay, you get yourself a leak in your house. What happens? Event. Now you have to call the plumber. He gets a little bit of information from you. He says, I'll dispatch someone out to your home to take a look. They take a look at your home. They see whatever might need to be done, maybe form the basis for some action, but they can't necessarily get it done then. They call the dispatch back, say, order me some parts. Go call a specialist. I need a permit, whatever it might be. Dispatch takes care of that for them. Okay? At the end, when they're finally done, they're going to send you any errors that might have come up. I can't handle this because you've got asbestos, whatever it might be, or possibly the invoice. I'm done. That's kind of the heart of EDA. The biggest advantage, as I mentioned before in my mind, DML and error handling benefits. It has one place of handling, so there's no need to write that again. So imagine this when you're doing your development. All you have to do is do your development. If you have an update to do, tell the dispatch. If you want to worry about the errors for that, all you have to do is communicate that to the dispatch where this might have come from. He'll take care of it. It's inconceivable to me some of the things I've seen. When it comes to error handling and DML, it's sometimes a mess, or sometimes they don't even bother to handle it. They just say update, just assuming that their code is so good, it's going to work. So EDA is simply one trigger for events, one dispatch to call the actions and provide all DML, and one or more services to do all the logic without having to worry about those DML or errors. Again, you're able to focus on your task at hand. And finally, it does allow for bypassing the trigger when desired, based upon whatever conditions you want, and duplicate entries into the insert update set. So now you know it won't get those annoying, it doesn't know which one to update because you have duplicates within your list. This will take care of that as well. So we're going to take a look at an example trigger for a custom object called account segmentation using Eclipse. So this is the old way. Actually, it's not. That's the new way. That's the old way. So I'm just going to show you really quickly. We're not going to get into all the code here. We've got a challenge on time. But all we're really saying is, okay, I've got all these records in scope. Let me go out there and find all the ones that are golden and find all those accounts. And then go get those accounts, so update those fields. So it goes through it, gets all the fields updated the way it wants, doesn't update. Good. This is hunky-dory. We've got it done. We did an update. And this is perfect. This is never going to break, right? I don't think so. So the pros on this, I have to say, it's bulkified. We have to admit that. And it's short. But other than that, there's not much else I can say about this pattern. It's going to break someday. Cons. I'm not going to get into all these here, but as you can see, and I think you can think of some of your own. There's a whole bunch of things, not the least of which is there's no error detection. And how your function is going to figure out what's happening. What about recursive calls? Okay, what happens if a future requirement comes in and now all of a sudden you have 30 actions you have to take instead of this one? I think you can see very quickly how this can become a mess. We had one trigger at our company that had become like that. And if you can imagine a single trigger, 2,600 lines long. We used this method, and now we were able to break each of those things into distinct actions, and you can focus on those tasks. So let's take a look at the EDA pattern, how it solves this problem. It is a bit longer, but you'll see down the road not only why it's longer, but why that helps you. So this is the trigger. If you'll notice, we have every single event covered. You want every event. Don't come back to this thing later and say, oh, I got to do an update, so let me add update to this too. Throw it all in there, because you'll never have to revisit this trigger again. It's done. And the best thing is nobody else has to revisit it either. Your analysts, your managers, nobody has to look at this. If you'll notice, the first thing in the lineup here is where we're looking up here on a custom setting we have, where we said, for this account segmentation trigger, I want you to say, did you even find it? And if you did, is the flag not null? And if it's not null, does it say disable? If disable, it's going to bypass this trigger. You've just bypassed your trigger whenever you feel like, outside of the code. You can add others to this. You can add other fields for profiles, for users, any conditions you want. You can throw right up front, and you don't have to worry about where in the code to put this. You can control it right there. Next, you're going to notice we only have, for each one of the events, we have one single action line right there. We're calling the dispatcher for something called trigger handler. We'll look at this mysterious thing in a minute. And we receive a map back. That map are your errors. We'll come down a little bit further. Here is how you are handling your errors in the trigger. Now, if there are obviously no errors being reported, you're done. But if there are errors reported, you'll notice we broke it up into numeric and non-numeric. So is there anybody out here who knows why we might have to look for a numeric instead? Can anybody think of? How about a before insert? Do we have an ID yet? That's the reason why we have that. So we're going to store the errors by the ordinal position of the list, because we know lists are ordered. So we're going to store it by the ordinal position, and if not, we're going to go ahead and use the ID that was created, but we had an error of some kind. So if it's an update, we've got an ID to tie it to. You could use the ordinal all the way through. I prefer not to. I prefer to use it this way in case you want to use the ID for other things. But that's obviously totally your thing to do. This trigger is done. You're never going to revisit this trigger again. So let's look at our dispatcher. Now, what is a dispatcher? The dispatcher in this case, it's his job to decide if there's something that may need to be done. He's not actually doing it. He's going to check and say, you know what, it's this event. I'm not being called recursively. Yeah, let's go do this. Let's go take a look at it. So we'll take a look at through here. If you'll notice, we have some rather unimpressive stuff at the top here. I have some other things in here to show you how to use upsert in here if you want to. That's more rare than the others, so I keep it commented out. So there's some unimpressive prep work going on in here as well. So boom, you have this here. That is all this thing is going to do. And the reason why this is so good is because your manager, your BAs, your functionals come in, they say, what the heck is your trigger doing? I'd like to know. Well, there's two ways to approach that. Number one, you can just simply have an Excel which says what, when, and what it does. And I'm going to give you an example of that in the chatter feed afterwards. But you can also have this out there and just tell them and train them. Go out to the dispatcher, look for the action method. And if you document that nicely, now they have a tool for their success. So let's just go a little bit further. We're not going to look at action at this moment. Whatever action does, it's going to fall through. The very next thing is we're setting our prevent recursion flags. And I hope everybody does use prevent recursion, because someday it's going to come back to bite you if you don't. There are times when you don't want to prevent recursion. That's why this is a nice little method, because you are able to set it and then let each action decide if it wants to fire prevent recursively. Okay? So, but I do them granularly on purpose, by the way, because if you don't do them granular, there's going to come a case where you want to prevent the after insert but not the after update, or possibly there's going to be a recursive call in from your update and you don't want to prevent that. So by doing it this way granularly, you've given yourself some extra flexibility. Here's where we're doing the updates. As I promised, it's very small. All we're doing is grabbing our updates, and if you'll notice here, we have add all from a mysterious map in the services. We'll talk about that. And once we get it, we do the update. You notice we're using database.update. Not using database dot is evil. And then once you get that, you go through your save results, and you figure out where your errors are. Once you have your errors, we throw it into the error map, and you'll notice I'm going into this error update map to get this index, whatever it is, that I'm on, and tying an error to it. This is set up by your services class. So there are only 2 lines necessary when we get to it to actually set your record for update, and then go tell this thing, by the way, when I'm doing this update, this is who asked me to do that, so you can report it back. This also allows for when you have objects downhill that do updates to you, they receive it back as well. So no more of these ugly errors on screen, dereference null object, all of that. If you do this properly, you get these nice errors that you can capture. Now, I've commented out these 2 pieces in here, but I always like to leave them inside the dispatcher for later use. In this case, I'm not doing inserts or deletes, so I'm leaving them out for now as comments, but I can easily uncomment these when it becomes necessary. I just want good coverage. Okay? We're going to talk about action. What is this mysterious action? That is it. That one call, that handles whatever it is you wanted to do. Again, he is not deciding what is to be done. He's deciding when it is to be done. The services will decide. And we'll talk about this other piece at the bottom in a moment. So in services, what is services doing? Well, there's all of our prevent recursive flags, okay, that we talked about earlier. We have some maps up here in the beginning. This is one of the changes to the pattern. And the reason for this is to avoid those duplicates within the list. Now that we have these, we will put things into this map. But imagine if you have an update, your very first action, you have an update for an account. You're updating the industry. Later on, you decide to add another action down the line. Now we're going to update these things called segmentation on the account. You could go out there and wind up saying, okay, I'm just going to go ahead and add that to the map. Well, boom, you've just went ahead and overwritten what you just did from the previous action. So that's what the pattern is going to show you, is that you simply go ahead and put this stuff into the map, and then go ahead and pull the stuff right back out if you needed to in a later method. Now you have both updates in the same record. We're going to go through it. I'm not going to even show you the logic because it's very similar to the one you saw before. As you can see, it all looks very, very similar. Okay? There is one nice thing right here. Definitely want to do that. And we're going to go through, we're doing a whole bunch of fields, but this here is pretty key, right here, if you'll notice. I'm giving myself a work object, and I'm looking in the map. Did I update this previously before in some other obscure method that might have happened prior to me? If so, go get it, put it into my object. Now I'm going to pre-fill it. So whether or not I got it or I'm updating it, this is still going to have both sets of updates or this one update. Now we put it back into the map. So now we have both sets of updates. This is the most important line here. That one line says which record requested this update. So if the account errors, when it goes to do it in the dispatcher, he can come back out and say, hey, segmentation, which one of you guys asked for this? Number 3. Okay, number 3, I got an error for you. Without this, you're going to get those ugly errors at the top, and nobody's going to be happy with that, especially your customers. I'm going to go down a little further. We have the catch for the error map. Same thing, you always want to catch these. What's coming back to this is errors in two forms. You have errors such as this one in the catch block, where you didn't expect this, you're trying to catch it so this thing behaves nicely. You're still going to report that back. That's your error map. These other errors are what happened for the requested DML. And by the way, if you have a before event, you can still do the updates right within here for the before event, just like you can in a normal trigger. So you don't have to worry about passing those back to dispatcher. And we pass back the error map. So in this case, it's just the catch block. Okay, well, we did a pretty good job on that. That one works nicely. So what else is going to happen here? Well, we've just received a request. We have a gap. We have to go out there and handle deletions as well. And when it's deleted, they want us to clear those values. Okay, so how do we do that? Well, that's likewise very easy. We come in here to the services. Remember I said the trigger's already there. The dispatcher's already there. We have to come in here, services. This is going to look very similar, except in this case, when it's going through, there's your map, there's your nulls, and then there is your error map and also your put and your error. Everything is a similar pattern. Okay, so how do we get dispatcher to handle this? You come back to dispatcher, boom, you throw in an action. You simply tell it whether or not you want to prevent recursion. Is it before or after? This is actually before, after delete. And then it goes into the services, takes care of it. You are done. Other than maybe a test method or two, you are done. That quickly. You didn't have to focus on where you're going to put this in. You didn't have to focus on your errors. You didn't have to focus on your updates or going through there for the success. It's all handled. This speeds up. Once you do this, this is where you get dividends. So, just in review again, you're going to create the services method first to create the accounts as necessary. You can concentrate on the task. You didn't have to worry about the updates. The dispatcher does it, already coded. You didn't have to worry about your error maps, already coded. And finally, you just added that one little thing into the dispatcher to make it happen. Done. Create a test method or two and tell your boss it's going to take you another half a day. So something about the design. First thing is, because script limits were effectively removed in Winter 14, you still have to worry about CPU time, but because they were effectively removed, that allows you to be more granular, more modular, and I like that. It allows you to focus on the task at hand. Other patterns can definitely be used. I fully recommend them. The singleton, any other methods or patterns that you seem to like can certainly be used in that services class, and I fully recommend them. Just because we can be more granular doesn't mean we shouldn't try to be efficient. At future, of course, must still be done in the services, as well as if you decide to call the new in-queue method that came up with the queuable interface this last release. Make sure to use not system is future when applicable. A lot of people still miss that. Whether or not it's a regular trigger or this pattern, it's still necessary. So there's going to be cases where you're calling this from that batch job or from something else that's in a future context. Now you're in trouble. At least look for it and at least handle it. Either say, I don't want it to run, or if you do want it to run, handle it. Say, want to write this off into a table so that it's handled at a later time. There are definitely test class considerations. The one consideration, the major consideration here is remember when your users are out there doing their job, they're doing distinct tasks, one after the other. They are completely different transactions. In your case, yours is all one transaction within that test method. So in this here, you would just simply have to call services and set your prevent recursion flags to false after each DML. As far as the services class is concerned, it's your first time. So for your non-developers out there, or maybe you want to bring this back to them, there's no need to read code. They can come down to the action method, and if you tie a requirement around it, now they know where to tie it back to. And they can start going through there and solving their own problems or questions. And after initial development, as you saw with that one enhancement, it becomes much faster. Once you can go out there, focus on the task at hand without having to worry about where and when and setting up the flags and turning it into a jury-rigged mess. And then finally, regression testing becomes easier and sometimes not necessary. I wouldn't go as far as that, but regression testing definitely is easier, and that's going to make your QA team happier, which is going to make your customers happy, which is the reason you're here, which of course is going to make you happy because you can spend Saturday with your family. And finally, there's a thing called snippets in Eclipse, which I love, and I'm surprised at how many people don't know about them. It's essentially templates for code. And the great thing about it is that you can create your code snippet, put in your placeholders for where you want your things, and then when you tell it to double-click it and you want to put in this code, it's going to prompt you for those 4 or 5 things, and then when you finally say click OK, boom, it gets all plugged in for you. This pattern works great with snippets. In 5 minutes' time, you can create your services, your dispatch, and your trigger in that order, and then move on to your services and start working on the task at hand. Again, not having to worry about error handling or DML. Just a touch about test classes. See all data equals true is evil. Say it loud, say it proud. Except, there are some cases where you have to use see all data equals true. Custom settings is not one of them. But you do have to use it for certain things, such as maybe you want to be able to run as a person with a certain permission set. Well, if you try to insert that permission set assignment first, you're going to get a mixed DML error. Maybe you have some static resources. You can't create those on the fly. You're still going to get that mixed DML error. So there are certain cases where it is necessary, certainly not as much as it's being used. Definitely create your own data. The reason you want to create your own data is because if you're going to have a good test class, you want to represent pros and cons. Let's say you have 3 things, 3 errors you're going to return from your services class. You want to create 200 of them, 50 of them good, and then 50 of them for each one of those errors. You're testing load as well as outcome. Outcome is more important than coverage. The users, I just gave a little snippet on the side there of how you might want to create a user. We actually have some utility methods where we have some overloads to where you can pass in, for example, the profile, and it will pass you back a user. Notice this does not insert the user. Run as is going to do that for you. And if you try to do it yourself, you're going to get mixed DML again. The other thing is start and stop test. A lot of people ignore this. It isn't just for a new set of limits. That's the one thing I always hear from everybody. One of the really nice things about start and stop test is you can handle your asynchronous events with this. So if you have a web service mock, if you have an app future event, if you have an in-queue job, if you put it within here, it's going to wait. Now outside the start and stop test, you can do your assertions on it. So you don't have to go through your tests and just assume your future methods work. You can test them this way. Definitely create reusable methods. As I mentioned here, we have a couple of here on the side here. We have a couple of overloads. We actually have a utility test class that's just for tests. Make sure you put @IsTest in front of it. That has over 40 different methods in it for creating data, for doing all of these sorts of things. And every single month, we're adding something to it. It's well worth using. And there's a little pattern at the bottom. Most important, assert, assert, assert. It's inconceivable how many people will say, I got my coverage, so it works. No, it doesn't. I would rather have 75% coverage with full assertion than 100% coverage with no assertion. Personally, my goal is 90% plus with full assertions. So here's your batch processing Easter egg I talked about. You ever get those too many concurrent jobs processing? And again, what I'm going to show you here works for test classes, but it can easily be switched around for actually batch processing itself. This impacts not only scheduling, but tests if you have a lot of batch jobs. We get this all the time until this pattern. Try this. Have you memorized it yet? Okay. We'll have to just look at it this way. Whoops, let me come back here. Okay. This is essentially what you just saw on the screen. All we're doing is saying, are there 5 jobs running? If they're not, good, process this for my testing. If there are, let's add 5 seconds. And I have to tell you, Winter 14 is what allows this to happen. Because before that, you would get too many script statements. Now, you won't. So if you tell it to wait 5 seconds, you can go into a loop and do this as much as 4 times. Wait as long as 20 seconds to see if you can get it to work. And if you can't, then you got a couple of options. You can say execute batch if you could get it to work. If you can't, you can either bypass the test for now because you know it's passed in the background before, or if you decide to use this for actually kicking off your batch, you can actually tell it to write it off to a table to where it can be kicked off later. You can even say execute batch and schedule it for 5 minutes from now to try again. So again, this would not have worked 6 months ago. But now that they've removed that, you can do this. But you want to do 4. You can do it as much as 6. I've actually done it with 6. But if you look at the debugs on this, you come very close to your limit of CPU time. You want to give it a little bit of time to actually execute and do what it's got to do. So I say 4. If after 20 seconds you don't have room, you probably have to worry about it not processing or at least queue it up for another run. So some final thoughts. I believe it benefits your scale and maintainability and certainly your development velocity. Once you get this put out in place, like I said, once you use snippets, 5 minutes, you're working on the task at hand. And so it's not only for the initial stage, but when you're making updates in the future. So you just ask yourself, where can you benefit? Maybe you can't. Maybe this doesn't fit your way of doing things. But the key here is you can make this as elegant as you want. You can throw an interface in there if you want to. You can implement an interface. My only issue with that is, for us, was that you have to worry about who's going to actually work on this after you. So if you're bringing in contractors or vendors, they have to understand them. They have to understand how you've used them. And then also, what happens when you have exceptions to the dispatcher? Certain things that you want it to handle a little differently than the others. I like the flexibility of having one dispatcher for each object. Even if you don't use it, hopefully it's going to send you down the road to start thinking of ways to start consolidating. Sometimes we bring in our patterns from our other languages, such as .NET or Java, and those things work beautifully there, not so much in Apex. So you have to start thinking about resources, you have to start thinking about the multi-tenancy, and I think this really helps us down that road. And once again, I'm going to show all my stuff that I've shown you here on the chatter feed, as well as an inventory sheet, as well as how to do snippets, as well as the slide deck. And as you can see, inconceivable. And now we're at the Q segment, questions and comments. And I want to thank you for your time coming out and not getting the good seats for Mark's presentation.